Hi, I am Vishnu Priya, working as an assistant professor in CSE department at JSREC Engineering College. Today I am going to present Unit 3, which covers multilinear regression analysis. First, I will explain multilinear regression, its equation, importance, and other applications. First, we are going to see what is multilinear regression analysis. It is a statistical method used to predict the value of one dependent variable based on two or more independent variables. The main goal is to understand how the dependent variable changes as the independent variable vary. The general equation is y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta n xn plus epsilon. Y is the target or dependent variable you want to predict. Beta 0 is the y-intercept when all predictors are 0. Beta 1, beta 2 up to beta n are the slope coefficients for each independent variable. X1, X2, X3 up to xn are the independent variables, otherwise known as predictor variables. Epsilon is the error term, otherwise known as residual for the model. Next, we are going to see the importance and applications of multiple linear regression. Multiple linear regression is a powerful tool for analyzing complex relationships between variables. Its importance lies in its ability to predict outcomes. It is used to predict the value of a dependent variable based on the values of multiple independent variables. For example, we can predict house prices based on the factors like location, size, and number of bedrooms. Next, we can able to identify the relationship between the variables. It helps to identify which factors have a strong influence on the outcome. Example, finding whether the study hours or attendance has a greater impact on the marks. Next one is control for confounding variables. Confounding variables means it is a third variable. It means controlling the influence of other factors that may affect the relationship between the main variables. Now let us see a simple example. Here, study hours to student marks. Here, study hours is a variable and student marks is also a variable. Study hours is an independent variable and student mark is a dependent variable. Here, third variable is present, which is an attendance. If we include attendance in the regression model, we can better estimate the effect of study hours on marks. Next, we are going to see the applications of multiple linear regression in various fields. First, we are going to see in healthcare industry. In healthcare, it is used to predict the health outcomes. For example, we can say medical cost based on age, weight, and treatment. Medical cost is estimated based on the age, weight, and treatment. Next, it is used in economics. It is used in economics to study the economic related factors. For example, we can find the income based on education, experience, and age factors. Next, in marketing. In marketing, we predict the sales and understand the factors that influence the customer behavior. For example, we can say we can predict sales based on the advertising expenditure, product price, and discount offer. Next, we can say it is used in engineering. In engineering, we use for predicting performance, quality, and efficiency of engineering systems. It is helpful for predicting the strength of a material based on the temperature. Now we are going to see the factor analysis. Factor analysis is a statistical technique and used to identify underlying factors from a large number of observed variables. It reduces many variables into a smaller number of meaningful factors. Variables that are highly related are grouped together. It is commonly used in survey, psychology, marketing, and social sciences. For example, we can say suppose a student survey has 10 questions about example teaching, infrastructure, exam, faculty support, learning resources. Factor analysis may combine them into a few factors such as teaching quality, learning environment, and academic support. Multiple linear regression predicts one dependent variable using multiple independent variables. It helps in prediction, relationship analysis, and controlling confounding variables. Factor analysis means it reduces many related variables into a smaller number of meaningful factors. Both techniques are useful for data analysis and decision making.